Right. Good evening, good morning. So we were talking about the storage, right? So in last classes we were talking about, so the storage and disk IO. Let's continue the same. So maybe we'll explain a little more so that we'll go with the DMVs that we have and the performance counters, and we'll show you how to investigate or how to track down that, so the performance issues with the IO, slow IO. So we all know, like whenever you perform any operations on the SQL Server, right? So anything, right? So either you read, write, or anything. So underlying stories should be involved to perform any of the IO operations. For example, let's say you're reading some data. So you want to read some data from the table, right? Select star from table name. If you want to execute that select star from table, and the page a table, underlying table, like has the data stored in the pages, right? So the page will be a store on set. Sorry. So we have a table, right? So the table has the pages and it is stored in the data file, so which is there in the disk, right? So whenever you don't have a page available in the memory, then the page should be read from the data file, that is disk, and keep it in the memory, that is an IO, right? So input and output, right? Whenever you are reading, so you will be reading the data. Whenever you are writing, right, so you will be writing into the data file, right? So that also read write involved. So before we jump into the diagram that we were talking, so let me show you one thing. So for example, select star from table. Okay. Mm. So I have this table, set statistics IO on, right? So this is the one way we can understand what is our statistics of this execution. So set statistics. Let's say you're executing a query, and you cannot capture either a profiler or extended events for an extended period of time, so you cannot execute, right? So in that case, you can execute set statistics IO on to understand your reads and writes of your query, right? Again, so you cannot even execute, leave this set statistics IO on and set statistics IO on for an extended period. So this is just to identify your performance of a query. 10 star from this, right? So I'll tell you, I have executed and I got 10 records. And if I see that statistics, right? So it tells that what are all pages, what are all tables it read, and what exactly it performs, what exactly it does. Order by ID. So I'm just doing some order by. So it has to create some internal temp table and it has to sort. So in the temp table. So that is why it is taking time to sort the complete table, right? So to get an order, like to get a, so top 10, it has to order the complete table, right? So it has to physically order the complete table and get the top 10 values. So that is the reason it is taking a little longer. So maybe I'll show you a different query. Adventure works table. Hmm. select star from adventure works person dot person top 10 order by business entity ID descending. Right. So it read that table scan count one scan, like so it just read through the complete table or that index that we have. And you see here logical reads and physical reads, right? Page server reads, whatever it is, read ahead reads. I will talk this. Okay. Logical reads, you have 18. Physical reads, you have 3. Right. So what does it mean? So, right. So it does the 3 reads physically. So pull the data, pull the pages from the disk, right? Because the pages are not available in the memory in the initial execution. So pages are not available in the memory. Then it reads the pages and keep it in the memory, and then it perform a logical reads, right? So whatever physical reads, though it read only 10, right? So it has to do order by. So it has to perform an order by. So order by, it has to read that and sort the data, and then it executes a query, right? So it perform this, and then we see here what is the scan and how many pages it read and how many pages it actually read from the disk, right? So you see here read ahead reads. So what does it mean? So first it needs only a few pages to read, right? While executing a query, so let's say for example I'm executing a select star from. So if I'm executing a query, in the initial reads it identify it needs further pages to be read. Let's say for example I need 10 pages to read. I need 10 pages. So if I need 10 pages, okay, so if I need to read 10 pages, so at the initial first page it identifies it at the initial first page it identifies, so it might need further pages to be read, right? It might the optimizer understand that it needs further pages to be read. So then what happens? The SQL database engine, it reads all the pages in a single read. It read all the pages and keep it in the memory, right? So it read all the pages. So that is what we call it as a read ahead read. So before even reading the actual page, it performs an ahead reads and keep it in the memory and perform the select operation or whatever write operation, right? So you will have to have a read ahead reads, because database engine understand that it might need to read all the pages to get the result set, right? Suppose if I don't have this order by, right? So let's say I'll restart the SQL instance. So if you restart the SQL instance, all the data pages will be flashed to the data file. Then you will not see. Okay. See, I have not done any order by. So it doesn't require all the pages to be, so complete table to be sorted and all pages to be read. So that is the reason. So you have that physical reads, right? So you have that physical reads 3, but you require 490 pages to be read, right? You don't need all the pages to be read from the memory, now from the disk, right? So of course, like these 10 records, whatever top 10 I have, this is not a physically, this might not be physically sorted, right? We are not sorting physically. That is the reason it has to read all the pages that we have in the, I mean, not all. So whatever pages which we require to read from this 490 pages, right? So that is the read ahead reads. It understands that I need to read 10 records. To read 10 rows, I need to read or scan 490 pages. So instead of scanning each and every page, or instead of doing each and every reads, right? So physical reads is costly operator, right? So if it perform around 490 physical reads, it is very expensive. So you will have that high IO latency. So to avoid that, it is reading even ahead of actual reads that data or the page. So that is the reason you see that physical reads are 3. So let's say in the first physical read, it understand it might need certain number of pages, right? So it might understand certain number of pages to be read to get the result set. So even it is actually reading that pages, it even ahead it is reading and keeping these pages in the memory, 490 pages. So order by business entity ID, so it might read, it will read. So since the pages, since these records are already available, or the pages already available in the memory, we are not doing any physical operations, physical reads. So all we see here logical reads. Okay, set statistics IO on. So you can off this IO so that you will not have that further queries executes this, so execute the detailed statistics of your query, right?
Chandru,
And we,
I have a doubt that if the query doesn't read from physical reads, then there is no read ahead reads. Huh?
correct, because the page is already available in the memory.
Okay, got it.
Hmm, right? So we have another, so that we will talk while performing query statistics. You have that set statistics time on. So it tells, like, so whatever the execution of your query, right? Suppose if you see the CPU time and elapsed time, it gives the detailed information, like what is your so how much time it spent on the CPU and how much time it actually takes to complete. This is the elapsed time, so that you will understand that either it mostly spent on the CPU or it is waiting for some resources to execute the query. So elapsed time minus CPU time, you will get the wait time, right? How much time it waited for to get the resources. So this you execute to get the information of your query. Let's say, for example, you are executing a query. Usually it takes 1 second or even few milliseconds. Now it is taking around 60-70 milliseconds. Let's say around 2 milliseconds the query executed, and now it is taking around 50 to 60 milliseconds. So when we talk about the milliseconds, the query is fast, right? 50-60 milliseconds is nothing, right? So you are executing and it is fast, right? To identify 50-60 milliseconds, if you capture that extended events or if you capture a profiler, it is nothing, right? You would not get much information from the extended events or profiler for millisecond wait time. So you will have to execute a query to understand or track down what it is waiting for, right? CPU time and elapsed time of this query. Set statistics time on. So you can execute set statistics time, comma IO on. So both you can execute to get the query. I mean, to get the statistics of your query, right? So you will have this all the details. Okay. So this is how we have to track down. And further, right? So we have how to troubleshoot any IO latency, right? So we have different mechanisms or different ways that we can troubleshoot or investigate the story IO latency. Either it could be IO, it could be at the SQL level or at the storage level. So SQL level, the reason that I mentioned, so you are doing a excessive IO, right? So you are doing excessive IO, then definitely you will see some latency while executing your query. Let's say, for example, you are doing a re-indexing. So if you perform a rebuild index or reorg, so anything if you consider it is an expensive operation, you will see some spike or latency of your execution, right? So you will see some spike in the IO metrics that we have, right? So let's see. DMVs, right? So this is one of the DMV that we have to identify the latency of your SQL server, right? So sister DM underscore IO virtual file stats. So virtual file stats, it tells that what is your reads, writes, latency of your executions, right? Whatever executions that you perform, right? So it under this database, whatever databases that you have, right? So whatever databases that we have, so it gives that file ID. For example, let's say I have this master file, this master database. I have a, so one is the MDF, second one is the log file, right? So it tells that what is the latency of your execution. This DMV will helpful to identify how many reads you are performing, right? Number of reads, number of bytes you read, right? So on this file, so what is the number of bytes that we are reading on this file? IOSTAL read millisecond. So what does it mean by IOSTAL read millisecond? That you are posted a read operation, right? So you have posted a read operation, and once we posted read operation on this file, right, how much time it took to get the data or result set, that is the millisecond. So what is the elapsed time, what is the time it took to complete the read, right? So IOSTAL read is 464 milliseconds to for this overall like number of reads, 61 reads, it took around 464 IOSTALs read milliseconds, right? 464 milliseconds to perform a read operation. So after you posted a read, so it took around 464 milliseconds to get the result set or to get the data. So likewise, you have this milliseconds individual file or the databases that we have. So here that is the number of writes, how much data we are writing, and IOSTALs to write, right? So how you posted a write operation and how much time the response, I mean, how much time it took to write the data into the data file, right? So after you posted a IO operation. This is the IOSTAL. IOSTAL is total read and write milliseconds, right? So this is the total of IOSTALs reads plus IOSTALs writes. That is what you see here, IOSTALs. This is the data size on the disk, whatever file handle that we perform. So I'll just execute this latency using this. These are just metrics, right? That we have. It is not giving any latency or anything. This is just giving the information of your queries, right? You will have to understand the latency with respect to the reads that we perform, right? So the latency that is respect to the the reads that we perform or writes that we perform. Suppose, for example, if you see the latency we are using calculating based on the reads, IOSTAL reads and number of reads that we perform, right? So if you divide this, so you will understand that how much time it took to perform a read of your query or of your load. I'll show you just. Moment. If I execute this, read latency. So if you see that read latency, this is in milliseconds, right? So this is 7 milliseconds, right? So you are reading data in 7 milliseconds. You are performing a read operation in a 7 milliseconds. That is your IO stalls read per millisecond divided read millisecond divided by number of reads, right? So if I use this, so what it is basically calculating, IO stalls divided by 61, right? IO stalls reads divided by number of reads. It tells that how much time it took to read this 61, perform the 61 reads, right? How much time you will have to calculate? You will have to calculate based on number of reads and the stalls reads. Like as soon as you posted 61 reads, how much time it took? Around 464 milliseconds to perform a read operation. So latency you will be calculating based on these two values. That is a read latency. At the same time, write latency. So you will see that IO stalls write milliseconds and IO write number of writes, right? So you will be calculating based on these two. Let me execute this. So I will share these scripts. So I haven't, updated or uploaded to the Git repo. So as soon as I updated this into the Git, and I will share this across mostly today. I will share these scripts for whatever queries which we are executing. I will upload to the Git and will share that across. Right. So read latency. So the same thing, right? So if you perform that anything, if you consider this adventure works, right? So this is 23 milliseconds and this is 57 milliseconds. Likewise, you have this latency at this time, at the same time, write latency also. This latency is the total of your read and the write. 7 plus 7 plus 0. So it's 7, 22 plus whatever value that we have it here, and you will have this latency. So on an average, how much data we are reading? Say average bytes per read, right? So you are reading this, and how many bytes you are reading, right? So each read, right? So 7 milliseconds, right? Each second, how much we are reading. That's it. So it is around this much data we are reading from these databases. You will be calculating latency here. Let's see if I can pull something. So let's start from dot votes, not votes, view object explorer details. Record votes. Okay, so I'm just reading some data, random. If I execute, so this is on this, right? Let's see if it executes. Where db name equal to okay 12, sorry, 13, right? So you see earlier it was 12, like we are reading, so additional 13 milliseconds it is reading, right? So this is how you will be calculating the latency using the DMVs that we have. So let me take you to the performance monitor. So performance monitor, so mainly we have I would say like a one average disk second per transfer. So that combines of average disk second per read, average disk second per write. So I told you earlier, right? So I preferably use that logical reads because it gives with respect to the architecture of the server that I have. Either it can be, so I mean, it can be either physical machine or it can be either virtual machine. So whatever that I have, so I will get the information using the logical reads. So average disk second per transfer. So average disk second per transfer, average disk second per read plus average disk second per write. The same thing here. So we are getting the read latency. Okay, so we got the data. So we get that reads, number of reads, so IO styles reads per second, read millisecond, this number of write millisecond, sorry, IO style write millisecond. So reads, writes combine this IO styles, right? So the same thing, we are performing a read and write. So average disk second per read, average disk second per write, you will get that average disk second per transfer, like how much amount of data we are transferring, right? So per second. So how much data, what is the transfer rate? Sorry, not the data. What is the transfer rate we are performing, so for to perform some IO operation, right? So you are reading into the reading from the disk and writing into the disk, and what is the time it took to perform your complete IO operation. So I'll just consider that E, right? Let's see. Order by ID descending. Let's see. See, the average disk second per transfer. So this is in millisecond, right? So currently it is in 4 milliseconds, right? So if you just monitor this, right, as soon as this is executing, and you will start saying that average disk second per transfer is increasing. So along with that, so what we'll have to identify how much data we are processing, right? So how much data we are processing at the SQL end. So average disk second per transfer, what is the time in milliseconds the IO is processing, right? This is a 4 milliseconds or even 5 milliseconds that you are performing. Now, again, if I consider that logical reads, not logical reads, right? So you understand that SQL is performing this 76, even, so it is going above, right? Like whatever based on your IO you are performing. So you see that average disk second per transfer is spiking up. So yeah, around 82. So you need to understand how much is SQL is processing the data, right? So how to find that? You have something called process. Process, we have that IO data bytes per second. So it tells that how much data a SQL, whatever process that we are executing, is taking up, right? How much data your process is currently running. One second. SQL Server stop. SQL Server stop. Okay. Sorry, stop. Okay. So while collecting performance monitor, so we see that multiple instances, right? I don't want all these instances here, so I just wanted to stop it here. IO data bytes per second, right? So you can see how much SQL is processing. So I see only one process here. I don't see multiple, right? For that reason, I just remove. I think this query got completed. Okay, some more data, right? So I'm just inserting like inner joining with the same table, right? So it exposes more, it executes more time, and so you will see more latency as well, right? So that is what I just use this join operator within the table. And if you see here, getting in result, okay. So I would bytes per second, maybe whatever I have, all the pages are there in the memory. So you're not performing anything. So without restarting the SQL instance, we do have DBCC clean, DBCC clean buffers. I think I don't recall, but yeah. If you execute the DBCC drop clean buffers, drop clean buffers, so that will be removed from the memory. Whatever pages which are there in the memory, so that will be removed, and it is kind of so the pages will be removed from the memory. Right. So if you see here, we are performing IO, and you see here, since we have high IO, right, read and write, and you have this IO average, this second per transfer is bumped up, right? So increase it to 104 milliseconds, and average disk write milliseconds and average disk read milliseconds are so increase it to a significant value. And you see here, right? So IO data bytes per second. So this much IO we are performing. This is just a one snapshot. If I just remove this, and it will be either increasing or even decreasing, right? So you will see a so the value of this IO data bytes. So this much data I am performing at the SQL end. Okay, so with this information, we are really thinking that it is an issue. So it is an issue with the storage. No, so you are performing a high read operation, high IO operation at the SQL end. That is the reason we'll have to understand that what is the current IO that we are performing at the SQL end. So based on that, so you will have to investigate further. And again, so this is one snapshot, right? You will have to capture a series of your, timestamp that you'll have to consider, right? Let's say, for example, you are executing for 15 minutes. So in that 15 minutes, you see that on an average, right? So on an average disk second per transfer is significantly high or normal. It is if it is only once time spike and the second time, like so on a max you see that high value, and so next you see a low value, so it is considered as a max. So you should not consider, you never consider that max value to investigate any of the issues performance issues. You will have to consider an average, that average based on the duration that we have. So any questions? I think someone is unmuted. So any questions you have? Right. The query executed, whatever data that we have. So we got this result set. Now I see the storage is the performance, like whatever reads and writes are idle now. I don't see anything. So this is one way that you'll have to investigate the latency.
Quick question.
Sure.
So is there a way I can fit on a particular workload to know the kind of IO he's doing using that perfmon?
Perfmon kind of workload as in like the queries that you're executing, whatever
Yeah,
workload.
that's
No,
I have.
No, performance just an indicator, like just you will have that metrics, right? So for example, you are reading, so how much we are performing, so how much data we are reading. So this is nothing to do with the any of the specific workload in the SQL.
Okay.
Yeah.
Okay.
You have DMVs where you can so capture the information. For example, if you see here, right? So if you execute, so you will have that so average, like a max load, total physical reads, total logical reads, execution count, and you can have that some DMVs to execute and get the queries that you are executing. So either it could be any queries, and you can capture this information, and it pulls the data, and you can get that information from the DMVs itself, not from the performance.
Okay, so this DMV data, would it be live running query, or maybe because I'm seeing query start, would it be something that is happening right now? If I have a particular workload that is running, maybe I'm doing a backfill and I needed to know what kind of IO I'm using. Is this something I can get using this DMV?
Sister DM exec query stats. So it captures the information from the available, from the, so in memory that we have.
Gosh.
And get the data. So it is not need to have a live information. So it is not a live data, right? So this is not, these queries are not live. So these queries I have executed a while back. So then it is capturing that information in the memory, and we are getting that info. But this will capture only for a certain time, right? So it also has some limit, like as soon as it reaches that limit, and it will be flushed that that memory, that queries from the memory. So if you want to capture historical data, either you'll have to use a query store. So if you have a query store that gives that information, whatever the reads, writes, that information will be there in the query store. That is one way.
Quick question. Sorry. Okay, go ahead. Finish your thought.
Go on. Okay. So second option, you can pull this data and so dump into some other tables, right? So you can execute this frequently and dump into some temporary table and store it into a database. So from there you can pull the data, and you can read that data for investigation. That also can be done.
Okay. Yeah. So another thing I was pondering, can you go back to the query result set of this query? So this query on the query string, when did you run those queries?
That's what, right? So this is these queries I have not run now. So after the few of them are executing in a backend, like for example, a master sister data file. So these executing in a backend, and few I have executed, right? So this is also I haven't executed because it is running from some extended events in the backend, the database, that I have not executed. This one I have executed, and this I have executed, right? So based on that, it is pulling. So it is not that I have executed it manually. It is even in the backend queries background. If executing by any jobs or any process, so it will be captured that as well.
Okay, but these queries are executed after your last restart, right?
Correct.
Okay.
Yes. So any questions so far?
Hello?
Yes, sir.
Yeah, you said the query were executed after the last restart. Am I correct?
Correct.
So if I understand you very well, you say this server was not, I mean, the last time it was restarted should be like some days back. Is that
Okay.
correct?
Mhm.
Okay. So
No,
if there
this
is,
server,
No, we just restarted it like
we
several
just
times.
restarted. Correct.
so, I'm just wondering how you got to have many queries on the query section
You
on the
mean
result.
result set? Okay.
Yeah.
And if you see here, these are all like, for example, except this and master database file order by whatever, like, so select host perform sys.dm underscore host info. So these are all like, so including even the background process that we are that, so SQL database engine executes, right? So I have not executed, or I never executed these queries manually. So even if if it detects like whatever background execution, so it captures in the sys.dm exec query stats and this dm exec query stat, and it gives that information here.
So I want to ask for a favor. Do you mind we having this query during the class session, probably in the chat?
Sorry, what was that? You want me to
I'm asking if we can always have this query during the class session.
forward this
So,
query?
yeah.
So I can do that, right? So if I just share this query here in the chat, you might or might not save that, right? So that is the reason what I was thinking. I will create a Git repo and will upload all the queries and will share with you. If that works, I will share that, so using along with all the queries. Otherwise, if you feel that you can save these queries and, so go ahead and, so save it in your system. So maybe I can share that here in the chat, but I'll have to
Sure.
send a plain text, right? Not as an attachment here. I
Sure.
believe by attachment I cannot send through Zoom chat, right? So I'll have to send a plain text. So whatever works for you, I'm good with that.
Yeah, both can work.
Right.
We
I can
need
share.
both. So when you put it on the Git repo, we just need the comments so that we know which query is doing what.
Definitely. I'll just, so suppose if you see here my, so file name, so IO latency with DMVs, right? So I mentioned here, so that I'll also add that class session class, so which class it is or whatever, if that is required. Yeah, definitely.
Okay,
I'll
so
have that same name.
yeah, so the reason why I was asking that question earlier was because I was wondering why we have so many queries after I restart, because I expected that DMV to have lost its information, right, after the restart.
Correct.
Okay.
So you maybe like, see, if this is the case, I can provide you this information. But if you want me to provide, so queries or details about each DMVs, maybe that is not, so easy like for me also, because you'll have to understand this DM exec query stats and all to get the details. But whatever queries I'm executing, and it is an aggregate or join with the other condition, other tables, other DMVs, and I will have that queries and will be uploaded to the Git repo.
Okay.
Cool.
Like you said, I think if we can get it too, fine, but that Git repo is also important.
That is true. Like you can save that, so in the future reference,
Future,
right?
yes.
Well, anyway, like I just pinged here, but again, right? So if you want me to ping, I can ping here, but I cannot, so send as an attachment here, right? So I cannot, you will not have that information. But as soon as you save this queries based on your understanding, like in your local mission, that should work. Anyway, I pin here in the chat. So any questions?
Sorry, I want to take you back to the time IO.
Performance monitor?
But no, I almost forgot. So the statistics IO, time IO one. So
Okay.
where you put set statistics IO on and set statistics IO time on.
Okay.
Yeah. Can you explain the differences.
Okay.
Yeah, so set statistics IO on, time on, then the other one set statistics IO on.
Both, right. So I mentioned here as just a comma, and if I remove here, set statistics IO time on. So I already explained the difference between these two. So you want me to explain the difference between these two?
Yes, I'll just a summary.
Sure. So let's start from adventure bus. Dot person. Right. So if you see here, these two. So this we got from the set statistics IO on. So it gives that what is the IO that we are performing. Set statistics time on, it tells that how much time we are spending to execute the query. So this gives the time, duration, I would say like time to execute the query. This tells like what is the IO that we perform to execute the query, IO. Reads or writes. With respect to it is a logical read or physical read. So set statistics IO on, it gives that read or write operations information, and set statistics time on, it tells the time we spent to execute the query. If you see here in the messages, output message and table, it read this table and it performed the scan count, total scan it is 1, and how many logical reads it performed and how many physical reads it performed based on the query, right? So whatever, right? Read ahead reads, I mentioned like it needs these many pages. So before even it go and read that each and every page, it even ahead, it reads that, it identifies that these many pages are required and it reads that these many pages into the memory. So because I just mentioned select start from, it needs everything to be read, right? Set statistics IO on, it tells that what is the logical reads, what is the physical reads that we are performing to get the result set. Set statistics time on, it tells that how much time we are spending to execute on the CPU, that is your CPU time, that is 63 milliseconds, and elapsed time, this is a 1485 milliseconds to get the result set. So elapsed time is even including the wait time that we are waiting to get some resources. It could be anything, right? It could be lock, it could be so any operations which is not currently running on the CPU. It is waiting for page IO latch. So that is also one wait time because it has to read from the disk and keep it in the memory, right? So that is what it is waiting for. And elapsed time minus CPU time, you will get the total wait time that this query is spending to get the resources. That is the difference. Is it clear?
Yes, thank you.
Sure.
Yeah, quick one.
Mhm.
Can you go back to the IO resource set real quick? No, not this one. The set statistics IO resource set. The one you just gone through. Yes. So the result. Yes.
Mhm.
The read ahead. You talked about reading pages, right?
Hmm.
You said it's pages, not the in terms of table cardinality, since you are doing Celesta.
So it is, these are the number of pages that we are reading. So
Okay.
let's say, for example, I have 100,000 records, and these 100,000 records split across 3,850 pages.
Pages. Okay. Okay.
This is total based on the total cardinality.
Okay. Thank you. That's what I want to confirm.
Mhm. Cool. Okay, let's move on. Now we understand the disk, the logical reads, I mean logical whatever performance monitor, and how much data I am processing, and whatever DMVs that we have to get the data or result set, right? So let's say, what is the ideal, so the way that we can tell that there is an issue with the disk, or there is a latency on the SQL server. There is a latency, disk performance or latency. So I was talking that, right? Suppose if you see at one particular time, and if you see that the average disk second per transfer is high, right? So let me show you this. So these all are average, right? So if you see here, and this is the last, like last time or last execution or last capture time, what is the, so spike, or what is the latency, and this is the average. So the duration, this is the performance counter live data, right? So that is the reason you have this within, so few seconds, or even so a minute, that data you will have, and you can capture this data in a result set, collect data collector set, and keep that running based on your need, right? So you want to leave that running for few hours, or for a day, or for a few days, right? So if you want to leave that capture running, so you can capture, you can, so create a collector set and execute that, and it will run in backend to capture the data. User defined, right? So new data collector set, right? Create a manual advanced, right, performance counters, like whatever it is, and you can add the performance counters here. So you can add the performance counters here. So whatever performance monitor, performance counters that we require, so we can go ahead and add that. Logical reads. Second per transfer reads writes, right? So all instances. So if you select all instances, whatever storage that we have, including mount points on the storage, so you will get that if you select the logical reads. So the same time, if you select the physical reads, average disk second per transfer, right? So you will have that high level, whatever disk that I have, it doesn't matter whether it is going for any so mount points, logical mount points or not. So it gives that physical storage structure. So I have two disks, it gives that information. Suppose if I have any mount points, so that considered as a logical, and you would not see that, right? So if the mount point is created inside that E drive, so you will have that overall latency on the E drive, not the individual mount points that I have, right? So that is the reason I usually prefer going with logical reads. So you will not see much difference, but yeah, you will have that, so mount point information as well if you use the logical disk that I have. Yeah, the second part transfer, all instances, right? You can collect and sample interval, right? So sample interval, so every 15 seconds it executes and captures that information, so that you require based on, so based on the need that we can capture and leave that running. So where we want to save that file, right? So where you want to save that file, we can save that anywhere in the local drive, and you can execute. Save and close, right? How to, so enable this save and close. or open properties for the data collector set when to execute, right? So you are executing, start the data collector set now, and we can execute, and we can leave that running, right? To investigate, so this is saving here, and to investigate, to capture that, you can go ahead and so open this file to get the captured whatever data we are capturing, right? You can stop it here, right? So right click and we can stop the data collector set, right? So this you can leave that whenever until we need, and we can leave that running, and we can get that information saved, right? So like this, we can have the historical data captured. But again, this is also a little overhead on the system, right? That is the reason we don't even leave that running. Even Microsoft, even Windows Server operating system level, we have not by default it is not enabled, the user defined or collector set. So it also requires some little performance overhead on the server. Either it can be a CPU, or it can be in a memory, or any performance issues, any performance overhead on the server. So that is the reason you should not leave this running instead. So you just require enable and capture, investigate the issue, and then delete this, right? And you remember, you will have to always go through that average, then minimum and maximum, so that you will not understand if it is a minimum and maximum, you would not be able to investigate the issue, the actual issue that we have. Yes. Okay, let's move on. So we were talking this, right? So we were talking so the diagram that we have. And so any questions? Cool. So let's say like you have some so latency that you have at the SQL level, right? So you notice some latency. So how you will investigate and how you will understand there is actually a latency of your execution, right? So first thing, you'll have to start with some weights. That also, even the weights that you will have to check the average, right? The particular duration. Sorry, like if you don't have any question, can you please put on mute yourself? Right. So you'll have to investigate with the DMVs. So we have a different ways to identify the weights, right? So one weight type is one DMV that we can validate, sys.dm underscore OS weight stats, or sys.dm underscore OS weighting stats. That gives the current or historical weight information. Start from sys.dm underscore OS underscore weight stats. Weighting task, right? So you have these two, and this gives the historical weights from the time we restarted the SQL service, right? So restarted the SQL service, and it gives that information. This one, what is the current waiting task? This is the live troubleshooting we are using, right? So what is the current waiting task that we are waiting on, right? It gives that historical information, wait time in milliseconds, and so you'll have that information here on the DMVs. Okay, so what is the wait duration of individual sessions that we have, right? So suppose if you want to do a live troubleshooting, this is one example that you can use. 1 second. Okay. Waiting task. let's execute this query. Select star from sys.dm underscore OS waiting task where session ID equal to 56. Right? So async network IO. Right? So this is async network IO again. So we are fetching a huge amount of data. Right? So the so the query we are executing, and it is a client fetch as in, so client, so different session is connected to the database, right? Either it could be from the application or from the SSMS we are executing, and it needs more data. So then it will be marked as async network IO, and it is waiting for the result set to be read. Right, so this is what we have, this async network IO. It is not necessarily that it is a network issue, right? If you see that async network IO, it is a high amount of data we are reading from the database, right? So until that is completed, you will have that, so this async network IO wait types, and wait duration is this. I think this is completed, right? As soon as this completed, and you will not have that wait type, right? First thing, so we'll have to identify so you'll have to check this wait type. So if any of the wait types, IO related wait types are significantly high, right? So if you have any IO wait types are significantly high. So if you have any of these IO related wait types are high, then you'll have to investigate the issue further. Is SQL Server reported slow IO? Right? So SQL Server reported slow IO. So let's say you have a high wait types, and all are indication of all are IO related wait types, and you see some latency at the SQL Server side, right? You are executing and you have to wait so much time to get the result set. So if that is the case, then you'll have to go further down. So if you don't see any high wait types, then no slow IO issue for the SQL Server. So it doesn't have any slow IO, then it is then and there, right? Now, so it reported slow IO, right? So it reported an IO issue. SQL reported an IO issue. Then check if physical or logical disk average disk second per transfer, right? That is what I was showing, right? So from the DMVs that we have, so if it is a reported slowness at the SQL Server side, so we'll have to check the average disk second per transfer size, average disk second per transfer rate, right? So what is the thumb rule of the average disk second per transfer, whether the indication of slowness based on your time series. Let's say you are executing around 5 minutes of data collector or 10 minutes. Whatever time series that you have collected the data, whatever the duration that you have collected the metrics, and you'll have to identify on an average disk second per transfer is continuously more than 20 milliseconds. Continuously more than 20 milliseconds. This value. So this value, you'll have to identify the value is continuously average disk second per transfer on an average, based on duration, either it is a 5 minutes or 10 minutes or whatever it is. And if this value is continuously more than 15 to 20 millisecond, based on, so the recommendations, normally Microsoft will validate if there is any latency more than 15 milliseconds, but you can consider that 15 to 20 milliseconds on an average, it is continuously on an average, it is we have a latency of 20 milliseconds, right? So on the storage, if you have a 20 milliseconds, more than 20 milliseconds, then we consider it as a we need to investigate on the storage, right? If it is a more than 15 milliseconds, right? So we have a few more than 15 milliseconds. It is a so you'll have to investigate the issue. Suppose if you have more than 30 or 50 milliseconds, right? So that the disk or storage is not optimal enough to perform your workload, right? If it is more than 15 to 20 milliseconds, you can consider this as a like you can consider this as a so slowness. But if you have more than 50 milliseconds, it is definitely a bad that you'll have to validate from the storage side, right? So you'll have in both cases, you'll have to see if there is any latency, if there is any issues with the storage. Right? Consistently, you see any latency, right? If you have a more than 20 milliseconds using the performance monitor, that is your either it is a logical or physical reads, the average disk second per transfer, you'll have to investigate, you'll have to identify and see if there is any slowness. That is your 20 milliseconds or more. So do performance counter, that is your perf indicates a slow IO, that is your average disk second per transfer is more than 20. If there is no indication of more than 20, but you still see some latency, IO latency, then you'll have to investigate further at the driver level, right? So even driver involves that read and write operations, right? Whatever performs, so you'll have to investigate the storage driver level, right? File system filter drivers. Work with a system admin, whatever, like, so you'll have to investigate with the storage team to make sure that everything is optimal. Driver filter drivers are not up to date, or whatever antivirus that you have, right? So the one thing I'll just mention that antivirus. So antivirus that we have, for example, if you use that antivirus, if you have not excluded this scan, if you don't exclude your data file or your SQL files from antivirus scan, whenever you perform any of the IO operations, that has to scan by the antivirus. The file has to be scanned. So we know, right? If you have an antivirus and if you're trying to access any of the files, it will check whether there is any malware or any of the issues with the issues while accessing, and it will be make sure that it is scanned by the antivirus. The same thing, you are performing some IO operations and the file is protected by the antivirus. And if that is the case, before even accessing that file, right, it will be scanning that, it will be protected and it will scan that the file and make sure that there is no so unauthorized access to that file, right? It will just scan that data file or any files that we have and make sure that there is no virus, there is no malware, so we have on the files that we have, either it is any files, right? So SQL files, even SQL server.exe, even if you have not excluded that, and while trying to access, so it will be, so latency, you will have a latency because it has to scan that file or exe to perform any of the operation that we have. So that is the reason you'll have to exclude that file from the antivirus scan, right? So as a SQL engineer, like, you might not be able to, so exclude that, and you'll have to inform to your Windows team to make sure that SQL files are excluded, even including backup file including SQL Server.exe or any of the exes it matters. And you also have to exclude data file and transaction log file, and even in the error log file, anything related to SQL Server to be excluded from the antivirus. If that is the case, you will see latency. Right. So I can tell you, like, if needed, I can tell you like how to identify if there is a antivirus scan or not. Right. So if we have something called process monitor, procmon, we call it as process monitor. It tells that whenever you're trying to access the database, if you execute that process monitor, it tells that what are all files it is actually scanning, right? What are all files it is actually scanning by what are all processes, right? So based on that, you will understand that, yes, while executing this query, there is an antivirus, let's say McAfee, and scanning this file, right? So you can identify using the process monitor. So I'm not going to explain that process monitor now, but that is just for your information. We have a tool where we can collect and understand the process monitor to, so understand like what are all files which is scanned by which process. So I can tell if you're interested in that. Okay, so the filter drivers that you'll have to identify and make sure that there are no filter drive. I mean, the filter drivers are up to date, right? So if there is any issues with the storage, and you don't see any of the latency in using DMVs, and you'll have to identify. So WPR, like, this is the external tool which usually used by Microsoft to investigate if there is any performance issues, because let's say we don't see anything. So outside Microsoft engineers, right? So we don't know filter drivers are causing issue or any antivirus is causing issue, and you don't see any, so you don't see any latency using the performance monitor, but you still see some latency or performance issues while executing your queries, right? So in that case, maybe if you open a case with Microsoft, so they might collect the WPR, like we call it as XPerf, extended performance tool, which captures the information to investigate that issue further, right? So this is not, don't need to worry, because we don't have, so some what I say, like DLLs or something to investigate this XPerf, right? So that is just mentioned for further investigation. So this is just a tool that Microsoft uses to capture and investigate the issue further if there is any slowness. Now, so if you don't have, then definitely you'll have to engage Microsoft to investigate the issue further. If your storage admin cannot find from the tools that they have, right? So you'll have to engage Microsoft to investigate the issue further. And let's say there is a slowness. Average disk second per transfer is slow. If you have the average disk second per transfer is high, more than 15-20 milliseconds, then is IO subsystem overwhelmed, right? So if the IO is, so you see here, like the slowness is reported, the average disk second per transfer is more than 20 milliseconds. Then next you will have to check if the data bytes per second is close to or beyond subsystem capacity, right? This is the thumb rule, like where, so Microsoft has provided, if it is a SAN drive, right? If it is a SAN drive, then average disk bytes per second. So if it is more than 300 MB, it is more than the capacity that we have on the SAN drive. So average disk second per transfer, or average disk bytes, sorry, not transfer, average disk bytes per second, how much data we are processing, right? So the thumb rule is, if it is a SAN drive, it is 300 MB. Right? If it is a 300 MB, this is the old matrix. Like nowadays, like all are, so we have a super fast SSD drives and all. If that is the case, that is okay. But if it is SAN drive, we have a limit of 300 MB. if it is more than 300 MB, this is beyond our storage capacity. So storage capacity, right? If it is a normal hard disk, then the capacity, the average disk bytes per second is 70 MB. 70 MB approximate it can sustain. If it is more than that, it is considered as, so overloaded on the disk, right? So that you'll have to check what is the SQL IO that we are processing, right? So how you will identify that average disk bytes per second? So same, right? So we can use a performance monitor, or we have something called process that I was showing, right? Process IO data bytes per second. IO data bytes per second. So how much we are processing? This we can tell how much SQL is currently processing on. So is IO overwhelmed, right? So you see that IO overwhelmed, like IO is processing high IO. Sorry. So if SQL is processing high IO, then you'll have to check further at the SQL level, right? I know SQL is processing high IO, right? So then what caused that issue? So SQL wide, you see that the latency, because SQL is processing high IO, right? So earlier we were talking, right? Suppose if you see here, while I'm executing this query, you see that IO data bytes you don't see now. Let's see. Restart. So what I would like to say, if you see SQL is driving more IO, right? If you see SQL is driving more IO, you'll have to investigate the SQL layer if any of the queries are, so performing a high IO, right? Let's say either your query, you're executing read or write, whatever it is, and you are reading, writing more, then you see that the query is performing a high IO. If the query is reading more, so when the query reads more, right? So whenever you perform any read operations, it has to read from the data, it has to read from the memory. Because if you have a proper memory configuration, the pages should be available in the memory so that you would reduce that IO operation. So if the memory is not properly configured, or if you don't have a proper memory available on the server, then you would be reading from the storage, right? Again, you will have to investigate if there is any memory issue on the server, right? So these are the few performance counters we can use to investigate if there is any memory issues on the server, right? So let's say buffer manager, page reads per second, page writes per second, right? What is the page reads and page writes that we are performing? This is the buffer manager. Okay, so we'll have to investigate. So I will show you that, so when we talk about the memory, but let's say if there is any SQL is driving, you'll have to investigate the memory issue as well, because if there is a memory pressure or memory issue, that also can lead to your excessive IO operations, because the pages, you don't have enough pages available in the memory, then you will have to read from the data file, right? So that you'll have to investigate and make sure that memory is properly configured. That is your max server memory. Otherwise, the pages will be keep flashing to the data file and you will be reading from the data file itself instead of reading from the memory. So you don't see anything, or you see some latency. What I mean, so you see here, you notice that is SQL driver, SQL Server driving the IO actively, right? You have this, and based on this performance monitor, you understand that SQL is driving more. Then yes, tune your query. So queries are causing this, right? So you have a excessive joins and operators, whatever you are using, you have a bad query execution. If you have a bad query execution, it is running for longer and it needs more data to be read. So that also we need to investigate that further, right? If the SQL is driving more IO, then you'll have to go for query tuning. Memory. So these are all, so dependent, right? One after one each other, like it is depending on one after another. If there is an IO issue, then you'll have to drill down or isolate the issue from the storage. If you don't see an issue from the storage, then you'll have to investigate the issue from SQL Server side. Let's say, and IO is not overwhelmed. Let's say you don't see SQL is not driving much. Then in that case, you'll have to go with the storage issue. So if you don't see any SQL driving much IO, then you will have to investigate the issue from the IO storage. If SQL is driving, then you'll have to go with further drill down into a performance of your execution, right? Either it could be a query tuning or it could be a configuration issue, that is your memory issue. Either it could be a backup or any reindexing or any of the, so rebuild, reindex, or any of the operations that we are performing on the SQL Server, that you'll have to drill down to a specific query that we are executing. Also checkpoint, right? So if you are frequently performing a checkpoints, that also not we, if database engine frequently performing a checkpoint, that also can leads to the excessive IO operation that we have, right? So you'll have to see, so how frequently we are, what is the checkpoint, so frequency, right? So we do have performance monitor to identify the checkpoint frequency. Just I'll show you, but I will talk that when we talk about the memory. SQL Server, MS SQL 2019. SQL Server buffer manager, checkpoint pages per second, right? So you have the checkpoint pages per second, how much we are performing that checkpoints, right? Lazy writer, checkpoints and lazy writer. So these also you'll have to check, like if there is any, so SQL Server is performing high, so checkpoints and lazy writers that we have high number of pages, so that you will have that. So when checkpoints, right? So checkpoint will check that if there is any excessive dirty pages, you have more dirty pages, it means you are doing an excessive IO, right? You are doing high write operations. If you have a high checkpoint, so you are doing excessive IO operation, not excessive, high IO operations, right? If you are doing a high IO operations, then the page will be marked as dirty and it will be keep on flushing to the data file. So you will have to identify what IO operations we are performing, and either that is, so any performance that we'll have to check, any bulk operations or any IO operations, what and how frequently that IO is performing and why. So we'll have to identify if there is any excessive IO, excessive read or write operations on the at the SQL Server side. So we'll have to investigate that further. So this is like, so again, right? So if you see IO, then you'll have to identify. If you don't see any of the SQL IO is processing, then you will have to identify the further, like, so this is not easy, but yeah, you will have to investigate which IO operation, which process is performing excessive IO operation, that is IO data bytes per second of that particular instance, right? It could be anything, any application that I have. Right? Collect, store, port, whatever it is a further deep dive, which we don't usually collect. So Microsoft will be collected that whatever store port traces that we have, and expert for, so whatever traces that we have, so it will be collected by the Microsoft. So we don't collect. So what are all Vmax can be done? So we'll have to check that any of the wait types, and you see if there is any latency. Average disk second per transfer is more than 20 milliseconds. Suppose if you have a more than 20 milliseconds, straight away we should not conclude that it is an issue with the storage. Instead, so we go with and check further, so IO data bytes at the SQL Server side, whether the SQL is driving more IO. If SQL is driving more IO, then we'll have to check the SQL, like what are all queries which are driving more IO. Then this query, it tells what are all queries driving more IO, right? So this tells the maximum logical reads of this query, right? So total logical reads, this is total is nothing but total logical reads that we last logical read, sorry. So this total physical reads, how much we are reading, how many pages we are reading basically from the disk, and last physical reads and execution count, how many times we executed this query. So this is the, so this is the DM background execution. We have that, so extended events, right? It collects that information and it is just giving that data. If I execute this, okay. If I execute this, as a target. Mm, 63. Execute. System exit query stats and total physical reads, exit query stats. Okay. Total offset, total KP. Okay. Max unlock. So maximum logical reads. Interestingly, I don't see the query.
Which query you're looking for?
No, the query which I'm executing.
It's still running, right?
Sorry,
It's still running. Or
it's
it's running.
running completed.
Okay.
Yeah. Right. So this query, and we see here maximum logical reads and total logical reads that we have, and the execution count, right? So so likewise, like we can understand that what is the physical reads and logical reads of the query. Okay, cool. So any questions? So based on that, we can understand like what is the logical reads, physical reads of the query that we are executed. So this, as I said, right, like this query starts, it captures from the memory that it is available in the memory, or so the SQL Server memory, internal memory that we have. But if you're trying to execute, so the query is currently executing, right? So if the query is currently executing, let's see this one. So if the query is currently executing, so we have a different ways to identify sys.dm exec request, right? One thing that you can validate. Otherwise, like you have something called activity monitor. Mm, Okay, so even you can use we can use the activity monitor to check like whatever query that we are executing, right? So suppose if you see here, 63 that we are executing. So it is waiting on this. And what are all, so what it is mostly waiting for. So resource wait. So you will have that information. So what it is reading on. Response time. Just give a minute. Right. So it gives the test. I think this is also capturing from the same query stats. Okay, fine. So this gives that execution count and CPU and what is the reads, writes, logical reads. So whatever we have this here, right? Average duration. So we get that information. But if you are trying to execute this query, select star from sys.dm underscore exec request. Okay, so reads, writes, it is not giving me. Okay, DBCC clean buffers,
Drop,
DBCC drop
drop,
clean buffers.
drop clean buffers.
Okay, DBCC drop clean buffers. clean buffers. And if I execute this query again, so this gives the physical reads. So this gives the reads that we are performing, right? So this is the physical reads that we are performing. And we see that IO data bytes. So you'll have to investigate you'll have to get the query and investigate, so the query which is running, either it could be a bad or it could be, so reading excessive data, or the query is expected to read the data, right? So that is something that you'll have to investigate and, so either fine tune, or maybe if the query is expected to execute and read more data, then we'll have to maybe increase the resources that we have, either increasing the memory or increasing CPU cycle. The query is executing longer on the CPU, right? So because of the memory, you see the query is running for longer because it needs more data to be read. So that is what I mentioned. So earlier, all are interlinked with each other. So if there is an IO, then there could be an issue with the memory, or if there is an IO issue, the memory is sufficient. If there is an IO issue, then it also can lead to CPU spike or CPU latency, because your query is executing longer on the CPU to perform some, so to get the result set, right? So all are interlinked. So you will have to understand, before we jump into the CPU troubleshooting, we'll have to understand the IO, and we'll have to understand the query tuning as well, right? So that's what we, so heading towards, like we are working on IO troubleshooting. So you don't see any queries now because the query is executed, and you will see only sys.dm exec request and while executing the query. Right, you'll have to investigate that query performance. So any questions?
Sorry, I have a concern.
Sure.
The select read write then all from sys.dm. Is this a right way of writing? I'm not sure. Putting star after the identifying the columns.
Sorry, I didn't understand. Like you are asking in this DMV, sys.dm exec request?
In this select statement, after
Uh-huh.
specifying the column you want, then you still specify all from sys.dm. So I'm asking the use of all, like this use of star after specifying the selected columns. Is it the best practice?
Correct, definitely. So it is the best practice of selecting only a few columns, then so selecting selecting all columns, because you no need to read everything, so from the table, right? So you just wanted to have that only a selected columns. That definitely improve the so the performance as well. But it also depends on, so the indexes that we have. Let's say, for example, you have index on 2 columns, right? And if you have index on these 2 columns, and it would be much more faster, let's say non-cluster index that you have, and you don't have an index on anything, right? So for example, let's say session ID, and you don't have an index on this. So if you don't have an index on this and you have an index on these 2, then based on the condition that we are using, it will go either, it will go either seek, it will either go scan of the clustered or non-clustered index, or it can go for some lookups that we will talk that later. But yeah, definitely if you have that selected columns, you will see a better performance than reading the complete tables, all the columns that we have in the table.
Just a little chime in. I think it was because you needed the read-write columns to come first. That was why you included them before you put a Celesta, right?
Correct.
Okay.
Correct. Okay. So any questions? On the storage IO or anything you had any occurrence of or anything you would like to understand, like based on your experience or anything. So I will so start query tuning from tomorrow. So IO, like if you have any questions, we can talk today. So anything which you might have end up or you might have seen your environment or anything that you would like to understand, either a performance monitor, DMV, or anything related, maybe we can talk now in next few minutes. No questions? Okay. Cool. So I will ask questions. Let's say, so yeah, so just a generic, like, so can anyone tell me, like, so any 5 weight types that we have and high level one line answer for them, for those?
Page IO latch, CX packet, and weight log, and
One line answer for those.
CX packet is parallelism. Page IO latch is a disk operation. Weight log is what? Sorry, the log operation, writing of a log operation, and I think network IO. It's waiting for network input output operation, and
Mhm.
I don't remember one more.
Okay, sure.
So let me help you with the last one, resource 104.
Mhm.
So resource 104 can be a query waiting for memory. Then you also have resource 104 compile.
Mhm.
Query waiting for memory for compilation.
Mhm.
So a scheduler wait when they're waiting for CPU to be available. So that answers the file.
Yeah. We also have HADL sync
Mm.
when the primary is waiting for the secondary.
Correct.
Yeah.
Cool. Cool.
Did you mention thread pool?
No.
Yeah, no, I didn't mention that one. No.
Cool. Cool. Great. So yep. So all, so, and anyone know, like, observe that flow control in always on, like I believe that you guys worked on always on.
Yes.
Not much.
Yes, we have.
Okay. Okay. So you might have observed that flow control as well, right? Like the HRDR flow control way.
The
Flow control
index
wait.
of
No. Sys dot DM sys dot DM underscore OS wait stats. Wait type like HADR transport, HADR database flow control, HADR transport flow control. I mean, this is not something related, but just wanted to say, like, if you have heard anything. Okay, I think I will talk that more when we talk about the always on. So anything else on the IO that you would like to understand, you would like to, so know about with
So
respect
if
to
IO crunches happen, we can see that the CPU performance issue or memory issue. Which one is most affected thing?
so because of IO you're talking.
Yes, yes.
So if you have a IO, that is, so symptom for others, right? So it is not something that because of IO you will see that CPU or memory. So you will have to investigate. Let's say, for example, you are running a query. So see, first thing, if application compliance that there is an issue with the storage, there is a slowness. So either application team or as a database team, we don't know if there is what is the issue. First thing. So let's say slowness. So if it is a slowness, we'll have to investigate one by one. First, when you got an issue, right? So application team stating that there is an issue with there is a slowness. First thing, what you'll have to understand, you will have to investigate. I told you, right? So either you'll have to probe more questions, either a specific process or specific query is slow, or the entire process is slow. If it is a specific query, you no need to even jump into a CPU spike, or you no need to even jump into an IO spike as well. I mean IO problem as well, because the problem is with the specific query. Everything is working fine, only one query is slow. Then you no need to worry about any storage, IO or anything. But definitely you'll have to investigate further, but you no need to worry about that.
Then
Let's say
we directly shoot them question that if it is a specific query, you have to tune that query. Is it right?
no, that's what, right? Like suppose if you inform them that you'll have to tune the query, what they'll have to tune. So you should have some metrics stating that this query is going for bad execution and this query is going with this operator. This query is these join conditions are not good, or this on operators are not good, or whatever something, right? So you will have to provide that information, and based on that, they will tune the query. Let's say query slow. Your statistics can be problem, your fragmentation can be problem, your index can be problem. It is going for a bad plan, or it is going for a parameter sniffing, or it could be anything which you can investigate or fix that issue. Then simply asking them to tune the query. Anyway, if they let's say that this query was executing fine earlier, right? 10 seconds executed. Today, it is taking around 10 minutes. So you cannot ask them to tune the query because it was working fine earlier. Now it is some issue without any changes. They have not done any changes, but you see some difference. In that case, definitely you'll have to investigate from SQL Server side, see if there is any issues for this query, either statistics, index, fragmentation, whatever that you have. If you don't find anything, I don't see anything, any issue, maybe you'll have to investigate this further from their development side. They'll have to check with their developer. But yeah, to answer your question straight away, we say that it is not SQL issue and you'll have to tune. No, that is not something that we'll have to communicate to them. We'll have to investigate from our side, then we'll let them know. Okay, to continue, like if there is a slowness of the query, then query tuning. If it is not a specific query, then our concern will come into. Our concern as in like overall server performance that you'll have to investigate. In that server performance, you'll have to investigate the CPU, memory, and more on IO. Let's say you don't see CPU spike, you still can have that IO. The query is reading more, right? So you don't see CPU issue, still you have that IO issue. You don't see memory issue, still you can have that IO issue. So you cannot conclude because of IO you will have that CPU. No. Because of IO you will have memory. No. So one or all you see that IO, and because IO is executing, IO is taking longer. You can see that CPU utilization, but it is not always. You can see CPU spike, you can see memory, but it is not always. And first thing you'll have to consider each troubleshooting separately, and one other can contribute to the IO issue. CPU can contribute to memory, and memory can contribute to CPU, and memory can contribute to IO as well. But it is not always that if there is IO issue, you will see that CPU spike. No, it is not always. At the same time, IO issue, you will always see memory. No, not always. But if you don't have a proper configuration of memory, then you will see that memory issue caused that IO, and you don't have that proper CPU. Let's say you have only 2 CPUs, and you are doing so much IO operation, and this query is keep on busy on the CPU and performing some huge operation. Then you will see that CPU spikes. CPU spike you see only when the query is running continuously on the CPU. That's it. Did I answer your question?
Yes.
Cool. Any other questions? If not, we'll conclude for today, and then we'll connect tomorrow, and then we'll go for query tuning.
Thank you.
Cool. Thank you all.
Thank you.
Sure. Thank you. Bye-bye.